Hello, in this video, we are going to talk about communication channels which are used in computer networks. Now we know a computer network is a group of computers linked to each other that enables the computer to communicate with each other and share their resources, data, and applications. Now these computers are linked to each other with different types of communication channels. These communication channels are also known as communication media or transmission media, and it is a path that connects the sender and receiver for transmission of information over a network.
This video, we're going to talk about Ethernet network cables that are used in local area networks, and I'm referring to twisted pair cables. These are the Ethernet cables that you'll find as you connect your computer to your router or modem so you can have internet access. One end of the cable plugs into your computer's network interface card, and the other end plugs into the network port of your router, switch, or modem depending upon what you're using. Now, Ethernet twisted pair cables come in two different types. The first type is unshielded twisted pair, which is by far the most common type of cable that is used today. Unshielded twisted pair consists of 4 pairs of color-coded wires twisted around each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of network cable is what most people use in their home or business. And the second type is shielded twisted pair. Shielded twisted pair is very similar to unshielded twisted pair, except that it has a foil shield that covers the wires. And this shielding adds an extra layer of protection against electromagnetic interference leaking into and out of the cable. This type of cable is mainly used for industrial purposes and not so much in a home or business.
We're here today to learn about wireless networks. We're going to look at their components as well as how they function. Before we get started, let's take a look at one of the International Society for Technology and Education standards that will be met by this lesson. Standard 3 encourages teachers to model digital age work and learning. Learning about wireless networks does this and shows fluency in technology systems that can then be transferred to new technologies. Here's the screenshot of the standard taken from the ISTE website. Now, since Bring Your Own Device days often lead to network questions, you'll be able to turn these questions into valuable teachable moments. Okay, let's get started with the basic definition of a network. A network's just to connect a group of people or things that share information with each other. A good example of this is your network of Facebook friends. Here on the right you can see your friend network. You're in the middle, and your friends are connected to you. So what's a wireless computer network? It connects computers and your digital devices through the air using radio waves. Wireless networks are commonly referred to as wireless local area networks, or just Wi-Fi. Wireless networks can be set up many different ways. The basic components remain the same. The heart of the network is the access point, and the links connect it to the nodes.
In this video, we will describe what happens in the modulation and demodulation part of an AM radio system. Now, AM radio may seem like so last century to most of you. In fact, there aren't that many stations that still do AM radio as their primary mode of operation. But it turns out that the concepts in terms of what's happening in the frequency domain actually are still fairly valid, in the sense that the specific modulation technique has changed, but there's a lot of similarity between modern digital systems and the AM radio in terms of how they operate in the frequency domain. So what I have on the screen here is a diagram of an AM radio system, and the idea is that we have a microphone that collects say speech signals or something like that, And the output of this microphone goes through an AM modulator. And the output of the modulator is the signal that's going to be broadcast. So this signal gets sent up into the antenna, somewhere up here. And then that signal is broadcast by the antenna to, let's see, what's a good color for electromagnetic radiation? Here we go. To the antenna of this radio. And so the idea is that the radio now wants to take the signal that's been broadcast and get the speech signal back so that you can listen to talk radio or whatever it is you're listening to. But the problem is that other radio stations are also broadcasting signals, and these other signals are also showing up at the antenna. And so the tricky bit is how the AM radio is going to select the signal we want from all of these other signals that are showing up. And that's the purpose of AM modulation and demodulation. It allows us to do that. And it turns out that analysis of this system really works best in the frequency domain because in the frequency domain you can see all the different things that are happening in the modulator, and then you can see what happens in the radio receiver as well.
Today my topic is fiber optic cable. Specifically, I will talk about the structure of fiber cable, single-mode fiber, multi-mode fiber, and their major differences. What is fiber optic? Fiber optic cable, or optic fiber cable, or simply fiber cable, is a type of cable that contains one or more optical fibers that are used to carry light. Fiber optic cables offer significantly higher throughput than copper-based cables such as coaxial cable or twisted pair cable. Optical fiber may be single-mode or multi-mode. Let's look at the structure of fiber optic cable. Fiber cable consists of center glass core surrounded by several layers of protective materials. The outer layer is a jacket. The insulating jacket is made of Teflon or PVC. The second layer is buffer, which is used to encapsulate one or more optical fibers and provide protection from physical damage. The layer around the fiber core is cladding. Cladding is made of glass or plastic. The cladding layer serves two purposes. 1. It protects the core. 2. The cladding reflects the signal down the fiber. In other words, light travels through the core by constantly bouncing from the cladding. Because the cladding does not absorb any light like a mirror, the light can travel great distances. Besides, the light bouncing or reflection from the cladding allows fiber to bend around corners without affecting the transmission signal. The center core of fiber cable is made of glass fiber. Light or LED travels through the core. Single-mode optical fiber is designed to carry light with a single mode, which means light wave travels in the same way or in the same pattern, and that gives us a single ray of light. Here are some features of single-mode fiber. Single-mode fiber can offer high transfer rates over long distances. The core diameter is very tiny, it's about 9 microns or micrometers. The width of the single human hair ranges from about 20 to 200 microns or micrometers. Without special equipment, we cannot see the core with the naked eye. Laser-generated light travels over one path, and the light does not disperse as the signal travels. Since single-mode fiber can carry signals many miles before repeating, that's why it's better for long distance, such as WAN connection. Internet backbone uses single-mode fiber. If you see a patch cable with yellow color, it is single-mode fiber. Multimode optic fiber is mostly used for communication over short distances like within a building or on a campus. Light waves are dispersed into numerous paths or modes as they travel through the cable core. Multimode links can be used for data rates up to 100 gigabits per second. Here are some additional features of multimode fiber. Multimode fiber core has a larger diameter than single-mode fiber. Laser or LED-generated light travel at different angles, thus it has greater attenuation than single-mode fiber. Module distortion is the sole problem of multimode fiber. Multimode is better for short distance. As I mentioned before, if you see fiber patch cable with orange color, you know it is made from multimode fiber. My topic is dial-up and DSL, two of the last mile technologies. The last mile refers to the segment or portion between local communication switching facility and customer premises, such as home and business buildings. The last mile is also called the first mile. I used to commute when I was a graduate student in Atlanta, Georgia many years ago. First, I rode my bicycle to the bus station close to my home. Then I took a bus for about 30 minutes. I got off at the bus stop on campus, and then I walked for several minutes to my classroom. In terms of networking, the first mile refers to the distance from my home to the bus station, and the last mile is the distance from the bus stop on campus to my classroom. In between is the network backbone. When I returned home after class, the first mile was from my classroom to the bus stop on campus, and the last mile was the segment from the bus station to my home. Thus, the definition of the last mile and the first mile is only relative to what direction I go. The last mile and the first mile mean the same thing in the networking field, and we simply use the last mile. Just a few words of my commuting experience. In the first week, my bicycle was stolen. Thus, my last mile transportation for next 2 years was basically my 2 legs. Last mile technologies refer to any telecommunication methods, devices, and media that carry signals over the last mile. Taking media as an example, the network backbone uses fiber optics, but the last mile may still use copper wires. Thus, the last mile is typically the speed bottleneck. Last mile technologies include dial-up, DSL, cable modem, broadband over power line, WiMAX, fiber optics, cellular, and satellite. Dial-up is very old technology which was commonly used in the 1990s. What you need is dial-up modem and a telephone number. When you dial up to the internet, it sounds like this. The maximum speed of a dial-up connection is about 56 kilobits per second. It is very slow, and you cannot use your telephone and the internet at the same time. But you were happy because you got the internet. Even now in 2018, the dial-up is still used by many users, especially those in remote areas and rednecks in the USA. Digital Subscriber Line, or DSL, is another last-mile technology that transmits data faster over traditional PSTN lines. At home, DSL uses existing telephone line and DSL modem. DSL modem separates analog signal of your telephone from digital signals of your computer. Thus, DSL does not interfere with normal telephone calls on the telephone line and does not require dialing a telephone number to initiate a connection. It is always on. A DSL modem is also used for communicating with a local switching facility. The device at a local switching facility which communicates with the DSL modem is called Digital Subscriber Line Access Multiplexer, or DSLAM. DSLAM is connected directly to the Internet. There are many types of DSL. Here I introduce 4. Asymmetric DSL, or ADSL, typically provides a faster speed in the downstream direction than the upstream direction. That's why it is called asymmetric. It is typically used by home users. Symmetrical DSL, or SDSL, is used typically by business for services such as video conferencing, which need significant bandwidth both upstream and downstream. DSL typically available to business also include high bit rate DSL, or HDSL, and a very high bit rate DSL, or VDSL. Here I try to skip the maximum throughput for each type. The reason is that they depend on many factors, such as different DSL versions in each type, different service providers, and the distance from the customer premises to their local switching facilities.
Hello and welcome to Science Everywhere. Bandwidth, we have heard this term, but what does it mean? Computers use the binary language of ones and zeros to communicate with each other. These signals of ones and zeros are transmitted as electric pulses. A high pulse indicates a 1 while a low pulse indicates a 0. Coming back to the original question of bandwidth, bandwidth is the frequency range over which a signal spans itself. Such type of bandwidth is measured in a unit known as hertz. Bandwidth can also be defined as the data transmitted per unit time, which is measured in bits per second or megabits per second. One important thing to be noted about bandwidth is that as it increases, the speed of your connection also increases. Here you may ask that why can't we increase the bandwidth of our connection infinitely so as to get an infinite speed? Well, wait a second, there's a catch. Bandwidth is not just directly related to the speed, it is also inversely related to the range. Hence, as the bandwidth increases, the range decreases. Hence, just in case you have a Wi-Fi router with a higher bandwidth, you may have a higher speed of connection, but the range of the connection will be low. The electromagnetic band in the bandwidth can be used in two different ways, namely baseband and broadband. You may have heard these terms, but what do they mean? Baseband, which is used in Ethernet connections, uses the whole band to transmit just one signal of information, whereas broadband, which is used in TVs, transmits a number of signals through the whole band. Another differentiating property is that baseband allows you to either send or receive a signal, but not both at the same time, whereas broadband allows you to send as well as receive the signals both at the same time. But when do we use each of these? The usage depends on the conditions for transmission. Baseband uses very low frequency waves which can deteriorate over long distances. Hence, they are used for short distance communications like communications over a local area network, or LAN like Ethernet. Broadband, on the other hand, uses very high frequency waves to transmit the information signal. Such waves can travel over long distances very easily. Hence, a broadband connection is used in long distance communication devices like television sets or radio sets. So now you know what the megabits per second speed of your internet connection means, and you also know the various types of band usages and where they are used. Thanks for watching Science Everywhere. If you learned something new, give this video a like and also subscribe for some more awesome science.
Today my topic is the difference between baseband and broadband. First, baseband. Baseband means two different things in the networking field. 1. Baseband is related to digital signal transmission, where the entire bandwidth of a baseband system carries only one data signal at a time. In other words, every single signal would require an exclusive use of the shared media. When I use the media, for example, no one else could be able to use it. They must wait their turns. Ethernet is an example of the baseband system. Regardless of their different versions, whether they are early Ethernet, fast Ethernet, or 10 gigabit Ethernet, they all contain the word base. They are baseband. 2. Baseband also refers to the original frequency range of an analog signal before it is modulated to a different frequency range. For example, an audio signal may have a baseband range from 20 to 20,000 Hz. When it is transmitted on a radio frequency, it is modulated to a much higher frequency range. AM and FM are two common modulated technologies in radio broadcasting. Now let's talk about broadband. The term broadband technically refers to any type of signal transmission technique that carries two or more different types of data in separate channels. Broadband signals can share one media. It's like a multi-lane highway. 2 or 3 vehicles can share the highway side by side at the same time. Broadband is also used as a marketing term for Internet access. This meaning is only distantly related to original technical meaning. In popular usage, broadband Internet refers to any high-speed Internet connection such as DSL, cellular, cable modem, or satellite. However, the broadband definition differs from country to country. In North Korea, the broadband may not be qualified as the broadband in USA. In summary, baseband is related to digital signals while broadband is related to analog signals. Baseband system does not allow a digital signals to share one media simultaneously, while broadband system can transmit different data side by side at the same time. For analog signals, frequency division multiplexing or FDM is used to make analog signals share one common media. For digital signals in a baseband system, time division multiplexing or TDM is used to transmit different users' data over one common media. TDM divides time into slots or intervals and assigns them equally to these users. In this way, everyone has an equal share. In general, baseband system is transmitting less amount of data than a broadband system.
Hello. In this video, we will cover different protocols which are used on computer networks. There are billions of devices which are connected to internet which communicate with each other seamlessly. In order for two computers to talk to each other, they must speak the same language. Internet needs to be very well planned and structured to enable this. That's where network protocols come in. Network protocols are a set of rules governing exchange of information in an easy, reliable, and secure way. These rules are the guidelines that regulates the different characteristics of a network, such as machine configuration, physical topologies, type of cabling, speed of data transfer, or internet access method, etc. Why do we have so many protocols? This is because when you talk to computer network, it is actually a layered architecture, and it is made of multiple layers, with each layer having its own set of protocols for communication within each layer. It then interfaces with layer above or below. We will not go into description of these layers, but we will go over some popular protocols which are used across these layers. First is Ethernet. Ethernet is the most important for LAN communication, and it serves the physical and data link layer. It provides the basic framework for data transmission. It divides a stream of data into shorter pieces called frames. These frames are encapsulated with destination address, error checking mechanism, and other information. These frames are then sent over a media like coaxial cable. Ethernet transmits the data in digital packets. If any computer wants to use this protocol, they should contain Ethernet network card or NIC. The card is implemented with unique address code fixed in the microchip. Next is point-to-point protocol or PPP. It is a data link layer protocol that enables transmission of TCP/IP traffic over serial connection like a telephone line. It divides a stream of data into shorter pieces called frames. It defines a framing method to clearly define end of one frame and start of another. It incorporates error detection and also includes additional protocols for bringing communication lines up, authenticating, and bringing them down when no longer needed. Next is TCP/IP, which is actually a collection of protocols and is the current standard for communication used for both local and WAN, which is the internet. The communication model of this suite is client-server model. A computer that sends a request is the client, and a computer to which the request is sent is the server. Most common protocols it uses includes TCP, UDP, and IP. Transmission Control Protocol or TCP is connection-oriented transport layer protocol which fragments messages into smaller packets and then sends them over the network. At receiving end, the packets are reassembled in the correct order to restore the messages again. It follows a standard handshake process with start and acknowledgement signals to establish the connection. Next is Internet Protocol or IP. It is a connectionless network layer protocol responsible for providing addresses to each computer and performing the routing. Once TCP breaks the data into smaller packets, it gives it to IP to provide addresses and to do the actual routing. Currently, Internet fully supports IP version 4 and it is moving towards adopting latest version IP version 6. Next is User Datagram Protocol or UDP. It is a connectionless protocol which allows packets to be sent without using handshake process. It is typically used to transfer small amount of information. Next is File Transfer Protocol or FTP. It is a standard for exchange of files across the net. It facilitates sharing of files between different computers or computer networks. It enables collaboration and use of remote computers. FTP is also the name of the program or command you issue along with the address of the site from where you want to transfer the files. It works as a client-server process. It is one of the most used facilities on the internet. Next is Hypertext Transfer Protocol or HTTP. It is an application-level protocol designed for transferring a hypertext among two or more systems. It is a generic, stateless, object-oriented protocol which can be used for many tasks. It is the basis for data communication for World Wide Web, where we have documents or web pages with hyperlinks to other web pages or resources which a user can access with a mouse click. HTTP is designed on client-server principles, wherein client and web server engage in a sequence of network request-response transactions called HTTP sessions. A web browser, for example, may be the client, and the application running on the computer hosting a website may be the server. HTTP has many built-in request methods which allow a client system for establishing a connection with the server machine for making a request. The server acknowledges the request initiated by the client and responds accordingly. For example, the browser submits a HTTP request message to view a web page. The server returns a response message to the client which includes requested content and status information. We now have an extension to HTTP which is called as Hypertext Transfer Protocol Secure or HTTPS. It is used for secure communication over a computer network. It is a combination of HTTP and SSL or TLS protocol. HTTPS encrypts your data and establishes a secure channel over a non-secure network. This ensures data is protected from eavesdroppers and hackers. It also authenticates the web server by checking whether it has a valid certificate by a trusted authority. You can validate this by making sure your URL starts with HTTPS and there is a lock sign on the navigation bar.
When looking at the list of components that make up the real lifeblood of a network, you have to begin by talking about the network adapter, or the NIC, the NIC. NIC stands for Network Interface Card. It's the lowest cost, most necessary component to have in order for computers, servers, printers, copiers, and any other devices to allow them to actually connect to a network. Now, you're not confined to just one network card or adapter on each computer or device. Some computers can use more than one network adapter card, and some network adapter cards can have more than one physical port or interface on them for use with connecting to the network. There are several types of ports you'll see on different network adapter cards. The most common you'll see is an RJ45 connector, which is similar to an RJ11, which you see on like the old analog phone connectors, and may or may not be interchangeable, but they aren't actually interchangeably functional wise. These tend to take Ethernet cables like Cat5, Cat5e, Cat6, Cat6e, and most recently Cat7. It allows them to connect. Those types of Ethernet cables can connect using the RJ45 port. You'll also find NICs that have what are referred to as SFP ports, as well as SC, LC, and GBIC or GBIC ports that allow fiber optic cables to connect to them. Now, there's more about fiber optic cables and connectors later. Just know for now that fiber optic uses light signals down a fiber optic glass cable that the GBICs and the other adapters on the ends of those fiber optic cables actually convert to electrical signals, or convert from electrical signals to light transmitting down those fiber optic cables. The proper cable connects into the port on this NIC card. Then this NIC card connects, usually, to the motherboard of the computer or the device itself. Now, I say this device because you can look at a network printer as one of the first examples of something that has a network adapter card for connecting to the network that isn't technically classified as a computer, even though modern network printer copier scanners are essentially high-powered computers made for their task. Now, most, if not all, desktop and laptop computers modern day come with built-in network adapter cards. However, with many of the desktops you still find today, the network card is not integrated into the motherboard, so you have the capability of upgrading it to handle different cable connections or adapters, or different speeds. These network cards also come in multiple different speeds, so you can typically find them in the standard speed that's being used right now more prevalently than you can slower speeds, but they are out there. Now, We're going to talk more about this in a later chapter, as I'm going to wrap up this lesson on network cards right now, but just know for now that each NIC, each network adapter card, is hard-coded with its own unique MAC address. MAC stands for Media Access Control, and it's hard-coded with this address number when the manufacturers actually make them at the factory.
As you know, I just finished my big research project on network operating systems. Is a network operating system? A network operating system includes special functions for connecting computers and devices into a local area network. Some operating systems, such as Unix and Mac OS, have networking functions built in. Here are all my main discoveries. My main discoveries include what a network operating system is, features of a network operating system, and common tasks of a network operating system. Discovery number 1. What a network operating system is. A network operating system sends electrical signals to other devices such as a printer, mouse, or a keyboard and tells them to perform specific tasks. Amazing discovery number 2. Features of a network operating system. These include having strict security features like user authentication or access authorization, clustering capabilities, file features such as printing or replication, user management features, and last but not least, internet working features like routing and WAN ports. Now it's time for discovery number 3. Common tasks of a network operating system. 1. User administration. 2. System maintenance activities like backup. 3. Security monitoring on all resources in a network. And 4. Tasks associated with file management. As I am such a good person, I will be using these findings to teach others about network operating systems. Thank you for all of your support.
Hi everyone, this is Modelload458 and this video is done for my school project about the local area network. Local area network is a computer network that connects computers within the limited area, such as home, school, or office building. The terms LAN and WAN are often mixed, and on this picture we can see the difference. The LAN would be just one house with PCs inside of it connected to each other. And the WAN would be many of those houses that are geographically far apart, but again all connected to each other. They would form a wide area network. The main standard used for connecting PCs over LAN is the Ethernet, and the explanation of the Ethernet can be quite complex, as we can see on many of those internet websites, but I'm gonna try and keep it fairly simple for you, just so that you can understand. Simply said, Ethernet is a technology which allows us to connect multiple devices to form a local area network. If you want to create your own Ethernet local area network, you'll need a Cat5 cable or the Category 5 cable. It's the main component used for creating Ethernet LANs. At the end of each Ethernet cable there's an RJ45 plug with 8 separate wires inside, lined in the exact order. I've seen many people confuse the Ethernet cables with the standard telephone cables, and in reality there's a big difference because the Ethernet cable has 8 wires whereas the telephone cable has only 4. The two other important devices for making networks are a router and the switch. The router usually connects two different LANs together and exchanges data packets between them, whereas the switch expands the single LAN network, with various devices such as other PCs, gaming consoles, smart TVs, servers, and a bunch of other stuff. This here is a basic LAN network with the switch being connected to the router and the router connected to the internet. There are multiple PCs connected to the switch along with the printer and the server. If, for example, you want to print something from this PC, it would be very easy since every device connected to a LAN can exchange data with each other, thus making the interaction very easy.
Hi, I'm Sean Carruthers and welcome to How Do I on Butterscotch.com. In this series we're taking a look at how to set up your very own home network. In this episode specifically we're taking a look at the wired aspect of your network. Now if you're doing this for the first time and you have a new device like this, one from Cisco that we have, a new wireless home network router, you'll want to know how to configure that into your setup. So if you have an internet connection coming in from the outside already, like a cable connection or a DSL connection, chances are you have it already connected directly from your computer into the modem that you have from your company, from your satellite provider, your cable provider, or your DSL provider. So the first step in this process is to check out the back of your network router. Now you'll have several ports on the back of this. Some of them are for the devices inside your house, and one of them is for your internet connection. So the first step is to locate the one for your internet connection. In this case, we've got one on the back that says Internet. In some cases, it'll say WAN, W-A-N, for Wide Area Network. So the first step in the process is typically remove the one that comes from your internet router and plug it into the one that says Internet. So we have that now connected into the router. So obviously that'll leave your computer disconnected from the network because it's not plugged in anymore. So you'll want to connect it up to the router. Now typically every router comes with an additional cable. So the next step in this process is to connect the cable up to one of the free ports that says Ethernet on the back of this. So we've got Ethernet ports. In some cases it'll say LAN or local area network. Then you'll want to connect the other end to the place on your computer where your modem used to be connected directly, like so. Now if it's cable internet you use to bring the internet into your house, chances are you're probably done at this point. Generally it's as simple as swapping the cable from your machine to the router and then plugging the router back into the machine, and then you're done. If you have another connection like DSL or satellite that requires specific authentication, i.e. a password to get connected to the internet, then what you'll probably want to do is you'll probably want to pull out the setup CD that came with the router. And this will allow you to run through the whole process and input that information in the correct place. Once you're done with that process, you should be good to go. Now if you're using a wireless connection, there's a slightly different way to configure this whole process, and we'll show you how to do that in an upcoming episode.
Hey guys, today we're gonna talk about WLAN. So, first of all, what WLAN is? W here stands for wireless and LAN is local area network. To understand better, we have to compare it with wired LAN, its preceding technology. Wired LAN means everything is connected with help of some cables like Ethernet cable. If you want to connect a single PC, then it's good for you, but if you want to connect multiple devices like mobile phone, printers and laptops, then it's not a good option because eventually, you run out of ports in your modem. And some devices don't even have Ethernet port. So, what you'll do in that case? You have to switch to the wireless network in this case. It removes the constraint, the need for a wire. A user can bring many devices to connect to the wireless network. To understand how data in the wireless network sent, we have to understand a little bit about physics background. Data in wireless network travel through free space in the form of alternating current in the section of wire which is an antenna. The current then create the electromagnetic field and travel at a right angle to each other. The wave which forms by electromagnetic field should keep changing, which mean continuous cycle up and down. Electromagnetic waves don't travel in a straight direction. Instead of that, they travel in all direction away from the antenna. At the received end, the process is reversed and the device induces an electrical signal, and if everything is working right, then the device accepts the signal. Now, The waves created by the electromagnetic field is measured in a unit called frequency, which means how many times the waves travel up and down in 1 second, and denoted by Greek symbol nu. The complete up and down is called 1 cycle. Frequency is measured in Hertz or Hz. There is a frequency spectrum ranging from 0 to 10 as the power of 22 Hz. The wireless technology which we used in our daily life fall in microwave and radar frequency spectrum and use 2.4 GHz and 5 GHz band. Keep in mind that not the entire 5 GHz band uses for wireless technology. Now, 2.4 GHz and 5 GHz band further divided into the sometimes called channel to avoid overlapping of two different frequency for two different devices. Each channel has a different number and is assigned to a specific frequency. The frequency range needed for the transmitted signal is called bandwidth. Now, these RF signals are physically difficult to measure as they travel through the empty space, so wavelength is a unit of measure how much waves travel through. The wavelength is denoted by Greek symbol lambda. Wavelength is inversely proportional to a frequency, which means higher the frequency, the lesser is the wavelength, which is why 5 GHz band cover less area than 2.4 GHz band. That's all for now.
Personal area network. As the name implies, the computing devices like desktop, laptop, printer or scanner, when they use for our personal use, they come under the personal area network. Let's try to understand personal area network connectivity. This type of network mostly used in home or apartment. Also, this network is located on either single desk or the devices in personal area network are near to each other. In this example, we have this laptop. Let's say we have requirement for giving printouts. For that purpose, what we can do, we can install a printer, and then we can connect this laptop with printer using either USB cable, or we can also connect by using wireless connectivity. So the laptop and printer we use here for our personal use, like creating the documents and taking the printouts. We know nowadays people use smartphones for storing the data like files or pictures. Let's say we would like to transfer files or pictures from this phone to laptop. All we need to do is to connect this phone with laptop using cable or using wireless connectivity. So here we are transferring personal files or pictures from phone to laptop using network connectivity. Let's take one more example. Let's say our next requirement is to use internet connectivity on this laptop. In that case, we can reach out to our local internet service provider and they can provide us the wireless router, which can be used to utilize internet service. After installing the wireless router, we can use internet service on this laptop as well as on the smartphone. Here we are forming network connectivity with internet as well. So if you notice, all these computing devices have formed network connectivity under certain range or distance. In personal area network, this distance remains under the range between 2 to 3 meters. So the personal area network is when we use desktop, laptop, printer, scanner or smartphone in our home for our personal use, and at the same time the connectivity among all these devices remain under the distance range between 2 to 3 meters, would known as personal area network.
Hello dears. Today we are going to study about metropolitan area network. So, as usual, let's start with a question that: what is metropolitan area network? A metropolitan area network (MAN) is similar to a local area network (LAN), but spans an entire city or campus. MANs are formed by connecting multiple LANs. Thus, MANs are larger than LANs, but smaller than wide area networks (WAN). A MAN is ideal for many kinds of network users, because it is a medium-sized network. MANs are used to build networks with high data connection speeds for cities and towns. The working mechanism of a MAN is similar to an Internet Service Provider (ISP). But a MAN is not owned by a single organization. Like a WAN, a MAN provides shared network connections to its users. A MAN mostly works on the data link layer, which is layer 2 of the Open Systems Interconnection (OSI) model. The fault tolerance of a MAN is less, and also there is more congestion in the network. It is costly and may or may not be owned by a single organization. The data transfer rate and the propagation delay of MAN is moderate. Devices used for transmission of data through MAN are modem and wire cable. Examples of a MAN are the part of the telephone company network that can provide a high-speed DSL line to the customer, or the cable TV network in a city. Well, have a good time.
LAN plus LAN plus LAN equals WAN. Local area networks are just not enough to serve large businesses and enterprises that span many locations and facilities. Companies that extend across a large geographic area need a wide area network, or WAN, that is not constrained to one physical location. Consisting of multiple connected LANs, WANs enable users to share and access applications, services, and other centrally located resources among corporate headquarters, branch offices across the country, and data center facilities. Enterprises traditionally design WAN architecture around factors like capacity, bandwidth requirements, connectivity, and user access. Organizations can use virtual private networks, or VPNs, to facilitate connectivity and security between WAN sites. WAN challenges include network reliability, security, setting up new sites, and performance issues that arise from latency and bandwidth constraints. Companies can increase bandwidth through leased lines, but these typically come with a high setup cost. WANs also require antivirus software and firewalls to combat potential security gaps that might compromise all devices connected to the network.
Network architecture. Network architecture refers to organization and allocation of tasks between the computers in a system. Two of the most widely used architecture models are peer-to-peer network or P2P network. In P2P network, all the computers connected have equal capability and capacity to use the resources available on the network. A peer-to-peer network is considered robust, as if one or several nodes stop working, the network continues to function. It is mostly used for file sharing. One of the earliest peer-to-peer file sharing networks was Napster, and the recent protocol is BitTorrent. Client-server network. In this network, a number of network clients or workstations are connected to a main computer known as server. There can be more than one server. Network topology. Topology refers to the physical or logical layout of a network. It defines how different nodes in the network are interconnected with each other and how the data is transferred between these nodes. Bus topology. In this topology, every computer and network device is connected to a single cable. That central cable is backbone of the network. Ring topology. In this topology, computers are connected to each other, with the last one connected to first one and forming a ring-like structure. It has exactly two neighbors for each device. Star topology. In this topology, all the computers are connected to a single hub through a cable. This hub is a central node and all other nodes are connected to it. Mesh topology. It is a point-to-point connection to other nodes or devices. All the nodes in the network are connected to each other. Tree topology. It forms a hierarchy. In this topology, there is a root node and all other nodes are connected to it. It is also known as hierarchical topology. It should have at least 3 levels to hierarchy. Hybrid topology. In this topology, combinations of 2 or more topologies are used.